Okay, I'd like to remind you what wrap-ups are. In this case, it's blood wrap-up number 1. During the conduction of the course, I get many questions during class, after class, during study sessions, and via email, or even in the hallway. These questions are from students that are trying to learn about blood in this case, or other subjects, and it's necessary for me to include some videos that are called wrap-ups because some of these questions are profound. After they are asked of me, I know that I should maybe explain topics further, or maybe I assumed students knew something and everybody was not aware of a certain fact, and that's what wrap-ups are. So this is blood wrap-up number 1. Okay, let's talk a little more about conventions. Conventions are constants that we're going to use throughout this course, and they may over summarize certain mathematical relationships, but it's just good to have a set number for some of these things. For example, here we go. 7% of the body weight is blood weight. That's what we're saying. So for all our companion animals, and you know it's horse, dog, and cat are the main emphasis, 7% of their body weight is blood weight. So if you have a 100-pound animal like a dog, then 7 pounds would be blood weight. This is something that can vary a lot, but we're going to say 7% of the body weight equals blood weight. Okay, so let's do another convention here. That's what the screen's about. Packed cell volume, we're going to say, is 45%. Now, packed cell volume is another name for hematocrit, and that means 45% of a blood sample is really cells. And it's basically red blood cells. There's a few white blood cells in there, but it's basically the cells. Okay, 1 gallon of water, and I say also blood, equals 8.3 pounds. Sorry, misspoke there. Blood is a little more dense, but for us in a beginning course, 1 gallon of blood, 1 gallon of water equals 8.3 pounds. Another convention, 3.8 liters equals 1 gallon. Now this gets to be the distinction between the metric system and the English system. When you go to the grocery store, you buy a gallon of milk. But a gallon of milk, if you look at it, it probably does say 3.8 liters. I'll have to go to the refrigerator and check that out, but that's probably what it says. Okay? Then we have 1 liter equals 1,000 mils, right? A mil is 1,000th of a liter, and if you take 1,000 thousandths, you'd get a liter. Okay? That's constant the world around. Then, some students don't realize that 1 milliliter is equal to 1 cc. So that's a constant, and that's definitely the case the world around. Then, if we're trying to do metric versus English system, 1 kilogram is equal to 2.2 pounds. Okay? And then I think finally on this slide I've got 1 kilogram, and a kilogram means 1,000. 1,000 grams equals 1,000 grams, of course. So there it is. Okay, I had a question on leukemia. If you remember, leuko means white, and emia means blood. So the term leukemia actually means white blood, and I've got an image for that here. When an individual, dog, cat, or human, has leukemia, that means you have white blood. And if you can see on this right-hand image, there's more white blood cells than normal. Usually they're in a ratio of 1 to 1,000. One white blood cell per 1,000 red blood cells. In leukemia, there's more than that, more white blood cells. And leukemia then is a word that means white blood. You might think that's good, but it's not, because a lot of times those white blood cells are not functional because they're being produced too rapidly. Okay, here's another term that we had a question on. Hematoma. Well, ends up being hema, is blood. And whenever you see oma, that means a swelling. So this is a blood swelling. And a hematoma, some people on the street would call it a bruise, but if you take this course, you can't call it a bruise. You've got to say it's a swelling of blood, a hematoma. And one good example of a hematoma that happens in dogs is an oral hematoma. Now, I know that sounds like oral, like the mouth, but no. This term, oral hematoma, means a hematoma in the ear of the dog. And of course, we have an image of that. And let's enlarge it, and here it is. Look at this hematoma in the ear of a dog. I'll do the margin with the laser pointer, probably there. Okay, there it is, an oral hematoma. Hematoma is a collection of blood, usually clotted, outside the vascular system. So it's blood that's outside a blood vessel, and it's often clotted, but not always. Okay, I had a good question on the blood clotting cascade. What is actually a cascade? Well, let's get this figure here and look at it. Cascade is something where one thing happens, and then that allows another thing to follow it, and then another thing to follow that. Perhaps the only thing I want you to learn from this complicated diagram is that there's a series of events that lead to a fibrin clot, listed here as a fibrin mesh. There's maybe several ways to start it. They call it the intrinsic pathway versus the extrinsic pathway. But let's just remember one event leads to another, and then that event leads to another, and it's in a series, S-E-R-I-E-S. It's a series of events. Another thing to take away from this diagram is that calcium is needed, the calcium ion, depicted here as Ca+2. Okay, that's one thing to get from this diagram. And here's another little depiction of somebody's summary of the cascade theory. Blood coagulation is a series, again, emphasis series of biochemical reactions. It's really making enzymes. They make material that are an insoluble state to a soluble state, and finally the end product is a fibrin clot. Okay, and so that means if you take this blood sample and you just put it in a tube, it becomes clotted. And the only way that doesn't become clotted is if you have an anticoagulant. And previous lessons have named 3 of the most common anticoagulants. And an anticoagulant is a substance that someplace along the cascade stops the cascade from further reactions. We also had a good question about blood vessel cannulation. I think I remember during a lecture talking about how you can insert a tube into a blood vessel, and they can come back repeatedly to take blood samples out of the tube that's in the vessel. Well, the blood vessel cannulation, or a cannula then, can also be called a catheter. So a blood catheter, blood vessel cannula are 2 actually terms. Let me show you a couple depictions of this. This diagram that somebody drew in a nice format talks a lot about what can go wrong, but I just want to talk about what can go right. Let me orientate you. Up here, this is the external surface of the skin of an animal. This is a tube that has been placed through the skin into a blood vessel. And so that's what a cannula is. It's a tube indwelling into a blood vessel. A lot of times it's a vein. And you can infuse material into the vein with that tube, or actually if you had a syringe on the other end, you could aspirate blood up into a vessel, or I should say a syringe, for example. Okay, so let me get rid of that thing and show you what they can actually look like. Now here's one that's not my picture, but I've actually done this with pigs, sheep, and cattle, where if you put one end of the tube into a vessel, a lot of times it's a jugular vein, and then you route the tube under the skin, and then in this picture I'm just trying to show you that the jugular vein, the neck of the animal would be way down here, and if you put a cannula in the jugular vein and route it under the skin to the back of the animal, this is right above the shoulder blades, you can have the tube exit the animal here, put a syringe on the end of the tube, and then aspirate a blood sample. And then you can, there's like a little valve here, you can shut it off and then come back later, a day later, an hour later, a week later, and take another blood sample. And if the animal isn't stressed, you get a pretty nice blood sample that's non-stressed. Okay, so here's a couple other points. A lot of times the tube that's routed under the skin down to the jugular vein, in this example, wants to clot the blood. So there's a couple things you do. One is you coat heparin onto the inner lining of the tube, and then whenever you flush the blood or take the blood sample and then flush it out, you use heparinized saline to fill the cannula or the catheter, whatever you want to call it, and it sits there. The heparin, of course, we know it's an anticoagulant. And the heparinized saline then sits in the tube, in the catheter, in the cannula, whatever you want to call it, and it prevents blood from clotting, and the next time you come along, you can take another blood sample.